column. Again, I will repeat now column. Anyway, I will going to repeat. Okay. So it is an example for IPv4, and this is an example for how IPv6 is look like. Okay. And the next one is difference between IPv4 and IPv6. Only few differences we will discuss. And I will explain what is IPv4. Guys, okay. So what communication we are using? So IP addresses for address type of communication. Guys, once again, so we'll see to communicate in the network, what are the requirements? Of course, need to communicate between the devices. First of all, the device must have an NIC. The device must have a NIC to connect in the network. And to connect the devices, what we need, if it is a wide type, then we need a cables. What type of cables we are using? We are using generally in a LAN communication, general LAN communication, we are using UTP cable. Fiber optic cables use only in some places. Okay. In our LAN communication, what we are using? Use wide type of connectivity, so UTP cables. And we are using NIC, its type is Ethernet, fast Ethernet, and or gigabit Ethernet. UTP cables we are using, and we are connecting the devices. Means either it can be a hub, simple LAN I'm telling, hub or a switch we are connecting, right? And this type of topology is star topology. Okay, and this is the connectivity to communicate. Again, so this is for creating network. For you want a networking means communication is required. So each one should be has an address with a logical address called a IP address. We are all using IP address based communication. Of course, these NICs having a MAC addresses, but that is a different purpose. Of course, MAC address is there, but we are not directly communicating with the MAC address. With the MAC address, we cannot divide our network logically. Okay. Okay. So we need an IP address. Of course, to communicate from one system to another system, we need different types of protocols. Depends upon the types of communication. Means you are communicating is a mail communication, or maybe it is a file transfer related, or maybe web related communication. So depends upon the type of communication. Okay, so we use different types of protocols in it. Okay, so this is what I trying to say. So what we use IP address, what we use TCP IP protocol suite. So here it is a upper, it is an application from types of communication it is, and then addressing and connectivity. So these are all defined inside your protocol suite, how it should be, communication should be happen, irrespective of what type of communication, what type of system it is, we should be communicate. Okay. So how it will be, communication is there. That's the protocol suite we are using, TCP IP protocol suite. And UTP or STP cables we are using, mainly UTP, unshielded twisted pair cables we are using. Star topology is our main topology, physical topology we are using. Of course, every NIC having a MAC address. And this MAC address is assigned by manufacturer of that NIC. NIC manufacturer only it is given. And this cannot be changeable. We can do some mapping kind of stuff, like a masking kind of stuff. We can able to do it, but we cannot change our physical address on the NIC. And
Sir,
presently, yeah, tell me.
so the MAC address is never unique.
Yeah, MAC address is a unique address.
But
Means in the world, only
it
one MAC address is there. Yeah,
is
tell me.
also as unique as logical address, right? As
No,
IP
no,
address.
logical addressing is different.
Okay.
Logical
No,
address.
I mean it is if like logical address, if it is uniquely, if it helps to uniquely identify device, and then MAC address also is logical or not, or is that also a difference between them, that it is not unique and
IP address. Okay, okay. And I got it. IP address is not unique address. It's uniquely identify the device address in the network.
Sir, IP address can be same for two different networks.
IP address should not be same in the same network.
but it can be same for two different devices but in different networks, right?
Yes, it can be.
Okay.
It can be. For example, in my
Or
home,
in the other hand, sir, MAC address is always unique because it is a
always
physical
unique.
address.
Like my system MAC address is different. And in this world, there is no same MAC address is available in entire world. But if I got one IP address to my laptop in my private network, same IP address, it may be exist in a somewhere else. So many places it can be repeated. Most common IP address network is 192.168.0.0 network. It means from 1 to so many things. 1, 2, 3, 4, 5 like that. And another one is this is the another most repeated IP address in the world in the private network. Public networks, public IP addresses are unique. It means if I have a server and the server having a public IP address, that public IP address won't be repeated in the or into any devices. But in the private IP addresses can be repeatable. But within the network, no same devices not having same IP. For example, these two devices are same network. Okay. So, and if I put a both are same LAN communication. If I put a both IP addresses are same, then it is a conflict. Then it is a conflict. So compulsory I have to use different host address. Okay, that's how it is uniquely identify device. This is identifying this device purpose. This address is to identify this device. And both should be in the same network address. Okay, that again we will understand by telling network and host portions, but both are in a uniquely identified device. But MAC address is unique address. It means the addresses cannot be repeated again. Okay. Okay, why IP address is logical address? Because it is divided into network and host wise. See, the host portion is different. This is 3, this is 2. But remaining portion is same. Means we both are in the same network and with a different host identities. Okay. So simple understanding of that logical network. Simply, I will show you guys. For example, I didn't given any roll numbers to you, right? So your batch is M3, okay, and Noida batch it is, and I didn't assign any roll number specifically. If I assign, for example, so I will assign this M03, 01, M03, 02, M03, 04, M03, 05, like this. So what is common? What is different?
So
This one is
M03 is same and the numbers are
yes,
different at the end.
yes. This is different. Why? Because of different people, their unique identity it is. Okay, and all are belongs to same batch. Get it? For example, I have a Noida batch 2, and also same I am giving. This is different logical batch. So obviously, obviously, this is different batch, and this is their identity. In this batch, each person number, their number. In this batch, their people numbers. Okay, this is how it is logically divided. This is like a network version. This is like a host version. So it is same for everybody in the same batch. Okay. Here by mistakenly I have done one thing, that is I written a 4 and I corrected it. But in case if I put a 4 here, what will happen? Instead of 5, this is one simple part. What will happen? Yeah, Deepak.
Sir, if MAC address is unique, that then who has the responsibility to look at that it should be unique for everyone in this world?
I will tell that. So one pending question is there. So can you tell what will happen if I put a same number for both the systems like this?
Collision.
Yes, it is like a conflict. So what happened? This person is, for example, Shiva, and this person is Ram. Okay. So for example, the Shiva is present. So I put a present here because I'm taking attendance with the roll number if in case. So same thing will happen, right? So conflict. So you should not assign same address in the same batch, same addresses like this. Here it is 4 is there, it is 4 is there. So both are different networks. So no problem. But here it is in the same network, same address should not be
So,
assigned.
sir, if the IP address yeah, IP address has this kind of a property in which the network makes it something, network makes it unique, and
Yes.
the host might not be might be the same, but the network should be different. But there's something which has to be different. It has to be the network, right?
The last
Because
point I said, actually, if a network means the network address must be same and host is different. It's make that unique from another network. Okay. So uniquely identification it is. In
okay,
case different network, same host, then they won't communicate each other. In the network I'm talking in generally, both are different. Automatically, there is no communication between them. So we need, so they cannot directly communicate. What we need a certain device which make a communication between the different networks. It is
so
nothing but our
in the
router.
same network, there should be different hosts which
Yes.
differentiate the different
Host
devices,
identity. Host
right?
identity. Yes.
Yeah, host is the one which define hosts are the one which decide the identity, decide the uniqueness of the device, right?
Very yes.
And in MAC address is completely unique, right? It
Yes,
makes it,
completely.
it doesn't matter which network we are using it in, it's unique. It's given by
Very
someone
good.
else.
Very good. Exactly. It does not matter which network you are. Okay. It does not matter which network. It's a MAC address is MAC address. We cannot change. It is fixed one. Every device has a MAC address, but we cannot control of the MAC address. We cannot divide
Right.
a device as per the logically. Like I have 4 systems. With the MAC address, I cannot divide these systems as logically. Physically, I have to divide it. Logically, I cannot able to divide. But with an IP address, I can divide these devices logically. Like this, by defining the network identity. No, cities, different networks. In that one, again,
So,
different
sir, in the
host ID.
in the history of IP addresses that are ever used, the networks should be unique, right? Because you can't repeat the same network and expect to expect the IP address to work differently, right?
In the LAN network, in the same LAN, in the same LAN network, okay, there is two parts, again, private and public. Private networks are there, public networks are there. I'm in my own private network. Okay, in that cases, okay, I should use my own network. So my network ID is different. Again, I can divide them into logically if I divide like that. For example, this is a different departments. So I assign an IP address like this. So it is 10.0.0.11, or maybe, yeah, 11 is okay. So this is 10.0.0. Because we didn't go to the IP addresses completely, you may not get it, but but I will tell little bit understanding. So I divide them logically. All four systems are physically connected, but with an IP address, I can make them logically different networks. So this to this communication is there. This to this communication is there. From this network to this network, no communication. I divide them logically within my LAN.
Okay,
Okay.
sir.
And if in case for same here also one more system is connected, it is also 10.0.0.13. So automatically it is become in this network only.
And this arrow which you are drawing between these boxes, it signifies that these are connected to each other, right?
Yeah,
That's part of
these
it.
can be able to communicate each other.
Okay, sir.
Now this is also communicate each other. Like this. These
Okay.
are all communicate each other, and these two communicate each other. But no communication between them with these two networks. Why? Because of both are different logical networks.
Okay, sir.
Okay.
Thank you. Thank
Right.
you.
Very good. Okay. So it is always there is a like it's not a easy also like both are addresses, both are it's like a more unique nature is there. So why there are not like that? So this is the main reason, as you said, that is a correct point. That is good point. It is with a MAC address, we cannot divide a network into logically. It is a fixed MAC address. And even though it is a unique address, in the entire world, it is a unique address, but we cannot divide them logically. We cannot control a group of network. This is a network, this is a network, like that we cannot control. Every device has to be connected directly. We cannot make them as a logically separated network. Okay. And routing is difficult. It means from my PC to somewhere like a google.com with a MAC address I want to communicate. Where is the MAC address? How many places have to go? Logically, it is not, there is no route, right? So obviously it is confusing. Maybe thousands of computer, it has to be searched and how to reach the google.com with the MAC address. That is absolutely infinite loops will create. Okay. But IP address is grouping like in a public communication for each country, each region, again, different public IP addresses is there. So like that, so routers with the help of routers, with the help of this region, continentals and the region part. So we can understand this IP address is which location and we can able to reach it. At least we know the route, an IP address because it's logically divided. Very good, guys. Okay. So IP address is a logical address, uniquely identify a device. Okay. Of course, can be changeable and it can be assigned automatically, or it can be get automatically. So it can be assigned automatically, or we can do it manually also. Automatically means by DHCP server. Okay. Again, I have written same thing. IP addresses, logical address, uniquely identify a device, can be assigned manually or automatically. Automatically means from DHCP server will assign an IP address to the our client devices automatically. How it will be assigned manually or automatically, I will show you that one. Okay. So IP addresses defines logical network, and every device must have an IP address. To communicate in the network, it required an IP address. Either it is in a local network or outside of your network, we are all communications by IP address only. Okay. And these IP addresses are two versions, IPv6, IPv4. IPv4 is 32-bit and IPv6 is 128-bit. 32-bit in the sense of 32-bit is 2 to the power of 32. Actually, 32-bit means 0 or 1, right? So like 1 0 1 0 1 1 1 1 1 0 1 1 0 1 1 1 0 like this. So 32-bit is there. Okay. So like this, 32 bits are there. Okay. So you want to count how many combinations are there from starting with all zeros. You want to combine like this. This is the starting one. This is the starting one. Okay. Then it will go like this. 1 2 1 1 1 1 0 1 1 like this. The binary number goes up to last like the I don't want to write. I can write, but okay. This is the last of our IPv4, last address of IPv4. This is the starting, this is the last. How many combinations are there? How many combinations are there? So we can try. This is one. Okay. 1 0. It keep goes 1 1 1 1 1 like this. It keep goes and reaches. This is the bottom. Okay, like this. You know how many things are there to know it? 2 to the power of 32. 2 to the power of 32 is our number of IP addresses. Okay, that is around 4.3 billion IP addresses we are getting. 4.3 billion IP addresses. Exactly, if you write, this is the exact number of 2 to the power of 32 number of IP addresses. Means these many are 2 to the power of 32, 4.3 billion combination IP addresses we are getting. Whereas in IPv6 is 128-bit. Again, it is 128 binary bits. If you write like this, all 128 zeros to 128 ones. Okay, so this 2 to the power of 128, 3.4 billion billions of IP addresses. Actually, there is a decillion, something name is there called a decillion. That is the 3.4 decillion things will come up. 3.4 into 10 to the power of 38. Those many combination of IP addresses from IPv6. Okay, and IPv4 represented in decimal format. IPv4 represented in a decimal format. IPv6 is represented in hexadecimal format. IPv6 represented in hexadecimal format. Okay, so this is our IPv4. This is a 32-bit number. This is a 32-bit number. Okay, this entire 32-bit is divided into 4 parts. This entire 32-bit is divided into 4 parts with a dot. Okay, this is part 1, part 2, part 3, part 4. So entire this number is divided into 4 parts for easy convenience purpose. Okay, each part has a 8 bits. If you see, each part having a 8 bits. This is one 8 bit. This is another 8 bit. This is another 8 bit. This is another 8. Totally 8 bit, 8 bit, 8 bit, 8 bit. 4 8 bits. What is 4 8 bits? That's it. Okay. And it is while for dividing, they use a dot. And each one is 8 bit. So each part we call it as a octet. Each part we call it as a octet. So 2 to the power of 8 is 256. Okay. So 2 to the power of 8 is 256. Means from 0 to 255 is the highest number. Means each octet range from 0 to 255. Each octet ranges from 0 to 255. Max number is 255. You can see this is the last one. So this last one you can also see. So these are all zeros only. The value of this is 0. This is starting 0 dot 0 dot 0 dot 0. This is the first. Okay, starting. And all 8 ones means it is 255. If you convert all 8s into decimal, then it is 255. So 255 dot 255 dot 255 dot 255. This is the last IPv4 address. This is the first, very first IPv4 address. This is the last IPv4 address. Okay. What is it? Octet. Each one we call it as a octet. The each octet range is 0 to 255. Octet means 8 bits. We have 4 octets, means totally 32 bit. You guys understand this part? IPv4 divided means the 32 bit is divided by 4. It is 8 bits. It is called as an octet. Each one is 8. Each 8 bit we call it as an octet. We have a 4 octets separated by dot. Octet means 8 bits. 2 to the power of 8. 256 means 0 to 255. The first one we call it as a first octet. This is first one we call it as a first octet. Second octet, third octet, fourth octet. Okay, that is a traditional name. But some people, for some convenience purpose, in certain textbooks, they use W, X, Y, Z. So W dot X dot Y dot Z for a portioning purpose. Okay, so but actually we call it as first octet, second octet, third octet, fourth octet. Okay. Guys, understand up to here? This part, IPv4 part.
Yes, sir.
Okay.
Yes, sir.
So we'll go to the IPv6, some more points. It is IPv6 is 128 bit. and represented in hexadecimal format. 128 bit, I cannot type 128 binary bits here, but we can do like this in a reverse calculation. Hexa means, the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So this is the hexadecimal numbers. Normal decimal numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is top. And then it will start 1, 0, 1, 1, 1, 2, 1, 3 until 19. Then 20. So it is changed until 29. Again 30. Again 99, 100. So this is how our sequence will happen, right? Here it is also after F. Again it is 1, 0. Okay. So F is the last one. Okay. So binary representation of 0 is 0, 0, 0. Even single 0 also okay. 0, 0, 0, 1. So I will go to the F. The binary representation is 4 ones. The last one we are taking based on that only I'm writing here. Okay. So F means 4 ones. So 4 bits has to represent one hexadecimal. If you want to represent a hexa 0 or hexa 1 or hexa 5 or hexa A, okay, it required 4 bits to represent that one. So one hexa number is equal to 4 bit. Whatever the value it is, one single hexadecimal is equal to 4 binary bits. So divide this by 4. 128 by 4 is 32 hexadecimal numbers we should use in IPv6. In one single IPv6, we use 32 hexadecimal numbers. Okay. So it is one hexa means who write in a bin? No, it's a bit. Okay. One hexa means 4 bits. 4 binary bits. So 128 by 4 is 32 hexa numbers. And we write 4 hexa numbers. For example, 1, 1, 1, 1. Sorry, we think it is a kind of stuff. Okay. A, B, 1, 2. This is a 4 hexadecimals. Each 4 hexadecimals, we call it as a one block. This is a block. And each block is divided by column. And we have 32 hexadecimals. And each 4 hexadecimal as a one block and divided by column. Okay. So like this, you can write. This is another block. Okay. Another block. Another block. So block 1, block 2, block 3, block 4. How many blocks I have to write? 32 by 4 because 4 hexadecimals. 8 blocks. In one hexadecimal, sorry, in one IPv6, we use 32 hexadecimals. And each one is divided, this 32 is divided into 8 blocks. Each block contains 4 hexadecimals. Each block contains 4 hexadecimals. It is totally 8 blocks. Okay. Total it is 8 blocks. This is how IPv6 is look like. IPv6 is 128 binary bits. Binary bits represented in hexa. Each hexa number required 4 binary bits to represent one hexa number. One hexa number. The top of the hexa single digit is F. Okay. So each hexa number, either it is, you can take 5. The 5 is represented like a 0, 1, 0, 1. Okay. That is 5. Hexa 5. If you take A is 1010. It's like a 10 in a decimal. 1010. This is representation. So each hexa required 4 binary bits. So 128 by 4. So we got 32 hexadecimals. So we have to write IPv6 is maximum 32 hexadecimals are there. And these 32 divided into 8 blocks. 32 hexadecimals are divided into 8 blocks. Each block contains 4 hexadecimals. And it is divided by a colon. And it is divided by a colon. I think I didn't write the here it is. The presentation is there now. That is enough. Different ways to representation is there, guys. If you see this one, this is totally 32. But this is not 32, right? But it is also 32. That is also 32. So you can see 0, 2, 1, 0, 0, colon, 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 A. The meaning is 2, 0, 0, 1, colon. This is first block. And the remaining blocks are zeros. Okay. So there is separate practice is required to understand IPv6. Okay. And this is another block. This is another block. And that is A, means this is. Okay. So that is a representation. So different representation, even it is smaller, colon, colon 1. It means first all are almost all 31 zeros are there. 31 zeros and 32 is a 1. Okay. So you have to write like that. So guys, again, IPv4 is 32-bit, IPv6 is 128-bit. IPv4 is 2 to the power of 32, 4.3 billion IP addresses, and IPv6 is 3.4 billions of IP addresses we are getting. Okay, and IPv4 represent in a decimal format, IPv6 represented in hexadecimal format. IPv4 example is 192.168.1.34. I have written out of one of the IP address from 0.0.02 to 255.255.255. And IPv4, this 32-bit is divided into 4 parts. Okay, as each part having 8 bits, so that each part we call it as an octet. So an octet means 8 bits. 2 to the power of 8 is 256. It means each octet size is 0 to 255. 0 to 255. And each octet contains the number is ranging from 0 to 255. Okay. The first octet we call it as first octet. Second one is second octet. Third one is third octet. Fourth one is fourth octet. In some places, we can also represent them as a WXYZ. That is for only simplification purpose. For our some people, for their own simplification, they use like that. But originally it is first octet, second octet, third octet, and fourth octet. As I said, each octet the ranging from 0 to 255. Okay, so no octet is more than 0 to 255, not more than 255. If I have an IP address like this, for example, 1.200.300.25. What is wrong in this one? 0 to 255, 0 to 255, 0 to 255. It is more than 255. It is a kind of wrong IP address. Not in any special cases also. Okay, guys, understand? No octet is more than 255.
Yes, sir.
Again, which will start from here. Guys, if you look at, I started at 0.0.0. That is the first one. What is the next IP address? For example, you take 3.4 billion IP systems and you started assigning one by one address. For example, just for example, understanding. The first one is 0.0.0. Second number is 0.0.1, 0.0.2, 0.0.3. It keep on going up to 0.0.254, then 255. Once you reach the 255, no 256. It will go for a 1.0, 0.0.1.0. Okay, and 1.1, 1.2, 1.3, 1.4 up to 1.255. Then it is become 2.0. It's like our numbers only 199, 200, 299, 300, 999, 1000. Okay, and 1999, 2000. So it is like once it is filled, automatically number will be added and it will increases. And 2.255, 3.0, 3.1, 3.2, 3.255, 4.0. Like it will goes up to 0.0.255.255. It is 2 octets are completed, then it is 1 will shift it to here. 1.0.0, 1.0.1, 1.0.2, 1.0.255 and 1.1.0. 1.1.255, 1.2.0, 1.3.0, 1.4.0. It keep on going. 1.255.254, 1.255.255, then 2.0.0.0, 2.0.0.1, 2.0.0.2, and it keep on goes like up to 0.255.255.255. Once it is reaches, again 1. Again 1.0.0, 1.0.0.1, 1.0.0.2. So like that 1.0.0.255 and 1.0.1.0, 1.1, 1.0.1.2, and it keep on going, and finally we reach this 255.255. What is the starting? 0.0.0, and what is the ending? 255.255.250. This is the total IPv4 range is 0.0.0.0 to 255.255.255. Okay, guys, understand that's the range I have written. It is 0.0.0.0 is the starting address, and what is the ending address is 255.255.255, and no octet is more than 255, and highest is 255, 255, 255. Guys, understand IPv4?
Yes, sir.
Sir,
Yeah, tell me.
sir, if IPv6 is a new version
Yes.
and upgraded, then what is the advantage of using IPv6 IPv4?
Okay.
Comparison with IPv4.
IPv6, there is small comparisons are there. IPv6 will give very high possible IP addresses, right? It is limited. 4.3 billion is a very limited at present situation. Okay, because of the computers network requirement, connectivity requirement is become very high. Okay, so we need an IPv6. And yeah, also saying I'm still working. I'm still working.
Sir,
One second. Okay. So current requirement for addresses for a devices, because if you see yourself, you have a mobile phone, secondary mobile phone, there is a laptop in your home, there's mobile phones, right? So more number of devices are keep on increasing. Next, IoT devices are increasing. IoTs are connected to internet nowadays. So we are getting more devices, and IPv4 availability in the public is become very less. And private it is okay, but in a public also it is become very less IP addresses. So we need a higher number of IP addresses. So along with IPv4, so researchers in IETE, IANA, ICANN, those people are formulated some other versions, IPv5, IPv6 kind of stuff, and they find IPv6 is much advanced and it is for another 50 to 100 years, no problem. Okay, so IPv6 gives 3.4 billions of IP addresses. More number of IP address we are getting, and compared to IPv4, IPv6 has certain additional security features, means the region wise automatically the region collaborations we are getting, and ISP provider kind of stuff, means if you are getting an IPv6, for example, you are using geo internet, you will get IPv6 address. So then it is divided like this, IPv6 address in that one, which region IPv6 is belongs to, which ISP provider it is belongs to. Within IP address only, that information is included as a form of within the IPv6 blocks only. Okay, so at least the host addresses we are getting is /64, means 64-bit host bits only we are getting, means in one single network 2 to the power of 64 host we can able to connect. It means is compared to IPv4, total IPv4 itself it is 32-bit, but here it is only host portion is 64-bit in a IPv6. So large network, large number of systems in a single network we can connect, and number of networks we are getting. In the entire world, we are using 1/8, not a 1/4, 1/8 part of IPv6 only we are using. Still, see how many parts are available. Still 7 parts are available to use. 1/8 part of IP addresses released into the public, only up to this part only. And there is other advantages of IPv6 also there or IPv4.
means we got a wide range of variety of numbers if we use IPv6.
Yes, with IPv4 variety of in IPv4 we have to assign IP address either manually or you should require a DHCP server to get an IP address. Okay, either you should assign or you should use a DHCP server to get an IP address. Like your router is a DHCP server in your home, like that we can use it. But with an IPv6, there is a link local IP address. Link local IP address. Okay, what is this link local IP address? System itself assign an IP address in the IPv6 format. It will assign its own IP address. Somewhere it shows like this. Link local IPv6. Using this address also we can communicate within the LAN, without you don't need to assign it, it will assign itself. It means system assign itself a link local IP address. So you don't require any DHCP server, DNS server. So obviously it is creating a own IP address itself by the system. So we can able to communicate with it. And using LLM and naming conversions with the names also we can able to communicate. Okay, and there is a different IPv6 also. Public addresses are there, private IP addresses are there, and global public IP addresses are there, private IP addresses are there, these link local IP addresses are there, and any cached IP addresses, multicast IP addresses also available in IPv6. But you may get a doubt. So if IPv6 having so many advantages, why are you using IPv4? Anyone understand the question? If IPv6 having so many advantages, why still we are using IPv4?
Maybe IPv4 is less complex than IPv6.
Of course. One of the thing is IPv4 is lesser complex, because if you learn IPv4, it is pretty straightforward. Only numbers we can able to see. In IPv6, even it is a very complex. It's look like very complex, but you don't need to do anything with IPv6. And at least one chapter will be removed from the network subnetting kind of concepts. Okay. Classifications and all, we don't know it. So just a simple basics point. So because general public people not at all required, basic level of networking, and IPv6 not at all required, because you don't need to do anything with it. Okay. Problem is, okay, in the world, because this is the network. Okay. So in the world, still there is a certain organizations and certain countries not completely migrated to IPv6. Still, they are using IPv4s. And as you said, it is IPv4 is lesser the complex, means simple you can easily implement, because the devices, the most of the devices support IPv6 and IPv4. Both the things it will support. But some of the devices support only IPv4, not IPv6. In that cases, again, you have required a conversion, like ISATAP conversion, like IP4 to 6 conversion, 6 to 4 conversions. Again, you need the conversion to use the network in IPv4 to IPv6 communication, because both are different protocols, different types of addressing. So one system is IPv4, another system is IPv6. We can't communicate directly because we need an intermediate system again. Okay, and in a certain organization, people think India is a very lack of country kind of stuff. It's not like that, guys. Itself in America, like a big countries, still using a IPv4 as their communication address. Okay, so there are organizations use an IPv4 addresses. Okay, in a certain private sectors, in certain countries, in the government level, it means entire countries, in certain private sectors are changed to IPv6, and still there are a lot of sectors, sort of countries still using IPv4. That's why IPv4 is also still become an important point. Okay, so once again, maybe in a 10 years or a 20 years, maybe everything can be a IPv6. Maybe we don't see, like in olden days, we have a tape recorders, that type. So we have a thing like when I was getting bored, I will tell to the younger generations like that there is a time IPv4. Okay, so you maybe, if once you are grown up, you tell to your kids. So there is a time we learn about IPv4. Now there is IPv6, no need to learn anything. Okay, that time your kids will become much smarter than yours. Okay, like Japan, Germany is much advanced, and there are small countries also, they know, like Ireland kind of stuff. They use an entire country's IPv6. Entire country they use a fiber optic connections. Right? Okay, not only Indians, America, like a country is also using IPv4. Okay, because we are bigger countries, bigger people means the larger organizations are there, are smaller countries. Okay, to clear the doubt.
Yes, sir.
Sir, sir,
Yeah, tell me.
sir, using both of them, IPv4 or IPv6, it depends on the number of customers they are having the organization. Because if they are having large number of customers, then they will go to IPv6. If they are not,
Possibility is there. For example, um, as I said, Geo use IPv6 mainly. And the actual plan is to get everybody into their network only. Okay. So a lot of people are disconnected ACT and other networks. Most of the people are migrating to Geo because the lesser the cost and fiber optical connection, it is there. And if you are any of you, either you or your friends or have anybody having a Geo internet, check their IP address. You will see the IPv6 address. Okay. So maybe their plan is India has a billions of people, right? Almost we are reached 1.5 billion. Okay. So almost at least a billion people will take a network. So there are a lot of connectivity is easy to manage in with the IPv6. Maybe based on the customers number of connections they use it. Okay. Security reasons they use IPv6. Okay. And as I said, a larger organizations within their self, within an organization. Larger organization means larger the network. So larger the network, it is maybe they will plan for an IPv6 to implement. Because IPv6 no need to go to each and every system to give an IP address. Okay, because in the private IPv6 address, if you assign IPv6 address to a device, automatically other devices will follow. Okay. In IPv4, it's not like that. You have to give IP address with the DHCP server, or you have to go to each and every device and assign an IP address. In IPv6, it's not like that. Once you define a network, it applies to everybody in the network. But for a backup, still a lot of organization using IPv4 also as a backup network. Okay. And here in this one, I didn't write more about IPv6, guys, about a, global public IP address ranges, link local address ranges, private IP address ranges. Okay. Any cached IP address ranges also I didn't written. So if possible, any notes if I find, I have a notes, then I remove, keep on removing one by one point. So that's why it is gone from here. Okay, so we'll continue IPv4 because our classes are IPv4 mainly. Okay, so there is a what is IPv4 range? Total range is what is IPv4 total range? 0.0.0.0 to 255.255.255, and these are the IP address are 0.0.0, 0.0.1 like that. Again, if you are using the IP addresses like this, there is does not matter about any logical part here. Okay, so we cannot see them as a logically separation. We are only seeing it an IP address. So we need a logical understanding. Logical separation is required. I can define a specific network based on the a logical addressing type. Okay, so that is the one reason. Second reason, and there is a beautiful question, that is the small organizations and bigger organization, guys. For example, in my organization, I have 100 computers. In another organization, there is a 200 computers, 200 devices, not computers, devices, right? Maybe in another organization, 1,000 devices are there. In another organization, maybe a 10,000 devices are there. So depends upon the organizations, depends upon the number of connectivities. So my IP network range to be easy to understand, means that easy to assigning part is required. Okay, so based on those things, means number of host addresses, number of devices basing the network should be defined, and next the network has to be defined logically. Network has to be defined logically. In those conditions, we divide this entire range into 5 classes. We divide this entire IP address range into 5 classes. Understand, guys? We're dividing entire IP address range into 5 classes. And we have taken this division based on the first octet of the IP address. We are taking this division based on the first octet of the IP address. Exactly, see the W portion. The first octet of the IP address. If you look at the first octet of an IP address, and we can tell what class of IP address it is. We're dividing IP addresses 4.3 IP addresses, 4.3 billion IP addresses into 5 classes based on the first octet of the IP address. Got the point? No one is speaking again. What happened? Oh, it's at 12 o'clock. Yeah, you have to speak. So we structured IPv6 discussion only. So I will complete this point, okay, up to here, and then we'll definitely take a break. And we should complete this IPv6 today. I thought I will complete maximum part of network, both parts. So, okay, no problem. Understanding is important, guys. So this is the ranges of IP addresses in the class manners. Class A, Class B, Class C, Class D, Class E. The Class A is 0 to 127. If you check in certain textbooks, it shows 0 to 126 or 1 to 126 or 1 to 127. Why there is a difference? The actual range is 0 to 127 only. But why some textbooks are showing 1 to 126? I will tell you that. Anyway, that is the, once I complete these points, I will show you that. Class B 128 to 191, Class C 192 to 223, Class D 224 to 239, Class C 240 to 255. The Class C 240 to 255 range is reserved for a research and development R&D purpose. In a certain places or maybe certain future representation purpose, this Class E range is reserved. So we cannot use in the public. Okay. Next, Class D 224 to 239 is a multicast addresses. Okay. Class 224 to 239 is a multicast address. What is meant by multicast address? It will only communicate between the certain devices, like a group communication. So for example, I send a message to your WhatsApp group, where message will go within the group only it is there. All the group members can able to see the message, right? The same way it is a multicast. Multicast means there is a certain multicast protocols are there, like a EIGRP. Okay, EIGRP, RIP version 2, okay, IGRP, BootP protocols. Use this multicast addressing, means both the sides same protocols and both will communicate with the same address. Normally, as I said, an IP address, two systems are communicating each other, means both should have a different IP address, right? Both should have a different uniquely identification address is required. Okay, that is called a unicast. But in a multicast, of course, the devices having their own unicast address, but they share information via single IP address using multicast address. Means these are exchange certain information between them based on certain protocol using a single IP address. That is a multicast IP address they use it. But they have their own unicast address. They have their own unicast address for this communication, for exchanging information only. They use a multicast address. Okay. And class A, class B, class C are unicast addresses. Okay. We should use unicast addresses. For example, I want to assign an IP address to my laptop. So I should use unicast address because one-to-one communication, one device to another device communication with a one-to-one communication it is. That is a unicast address. Okay, we cannot assign or configure IP addresses to the devices. What IP addresses we cannot assign? Below IP addresses to a or any device. Okay, what it is? 0.0.0 is a reserved IP address used by certain protocols like a DHCP or default routing protocols use this kind of reserved IP address 0.0.0. Of course, sometimes this IP address represent no IP address kind of stuff. Okay, so 0.0.0 is representation is any IP address, no IP address, or no condition, or a fixed condition kind of stuff. In certain different protocols, we use this kind of representation, including DHCP client use this 0.0.0 for finding a DHCP server. And entire 0 series, the 0 with anything, starting with a 0 and the next one is anything, we cannot assign. We cannot use means we cannot assign or configure these IP addresses to any device. Any device. Next one, 127.0.0.1. It is a reserved IP address and it is every device is assigned with this IP address. Every device. My laptop having an IP address, yes. My laptop is having its own IP address. Your laptop having one IP address. Other laptop also having an IP address, right? But itself communication means this is a device want to communicate to itself or to test itself for a TCP IP protocol is there or not. They use this 127.0.0.1. 127.0.0. Every system, their loopback or localhost IP address is 0.0.0.1. Loopback or a localhost IP address. For example, this actual IP address, the PCA actual IP address is 10.0.0.2, 10.0.0.3, 10.0.0.4. Okay. If I want to communicate from A to B, I want to send a ping request, for example, then 10.0.0.3 from A. Okay, from A. What I do, I'm pinging to 3. It means I'm sending a ping request from A to B. Same from A, you're sending ping request to 127.0.0.1 means you're sending a ping request to A only. A to A. Okay. For example, here I installed a MySQL server. MySQL server installed or Oracle SQL Server installed. This is server application and there is a client application. From client to server, I want to access. Both are in the same system. I will use 127.0.0.1 to access from here to here. Here to here. Sorry. Client to server, both are in the same system. So I use 127.0.0.1. But from here, you want to access this MySQL server. So you have to use the client. So 127 not bound. So 10.0.0.4. Okay. So within the system, it's a self-testing purpose, self-access purpose. We use this 127.0.0.1. Okay. Self-testing, self-accessing, use local host address, that is reserved IP address is 127.0.0.1. And 0 to 127.0.0.1 entirely we cannot use it because it is all 127 series is reserved. And also we cannot use class D and class E also we cannot use it. Okay, because class D is a multicast, we can't assign. Class E or ND we can't use it. Okay, and these are used by certain protocols, so there it is useful. And class A, class B, class C are unicast, which we can assign to our devices. Of course, there is a conditions. Okay, of course, there is a conditions are there. Okay, and of course, entire 0 series or start with a 0, we cannot use it. 127 series and 127.0.0.1, we cannot use it because of it is a loopback or a local host address. You guys understand up to here?
Yes, sir.
The last one, and before we take a break. So we discussed the classes, class A 0 to 127, class B 128 to 191, class C 192 to 223, class D 224 to 239, class E 240 to 255. And identify these IP addresses, which class it is belongs to. And when you see an IP address, don't see anything, only see the first octet. Always see the first octet. Okay, and see the first octet is 137. And where is the 137 in between a range? 137 range is in between 128 to 191. Okay, it is a class B IP address. It is a class B IP address. Can anybody identify this one? 156.178.1.10, 1.44. Which class it is? 156. Answer first.
Class B.
Class B. And this one? Simple one. Is a class A. Why? Because of 10. You have to look at only the first octet only and see 10. 194 to 10, 34. Look at the first octet, 194. Very good. Class C. 227. 127.
D.
Class D. Very good. Okay. Like this, you should identify which class of IP address. Guys, here in this important points, what is an IP address and how it is different from a MAC address, and what is a MAC address, what is IP address, differences that we have taken more time to explain, right? And what is an IP address? Okay, what is an IP address? And small differences between IPv4 and IPv6. And what is an IPv4? and IPv4 total range. Okay, and very important is IPv4 classes. IPv4 classes. And one more is this is another important point. Another important point is this one. Okay, so 127. Next, identification of IP address, which IP address, which class it is. Okay, so that is the point. The next one shall tell you the network and host portions, of course. So take a break, guys. It is 2:14. Okay, come back at 2:30. Okay, so take a break.